Now, before section D, we're going to just think a little bit about how we can use Pythagoras' theorem in a non-right angled triangle. And actually, if we look at the original triangle here, and to calculate the area of this triangle, you can see what we've actually got is a isosceles triangle. And we said at the very beginning of this chapter that Pythagoras' theorem should only really be used if you have a right angled triangle. Now, what we need to do is split the triangle in two. As you can see here, what we then get are two right angled triangles. Now, to calculate the area of a triangle, we need to do area equals a half times the base times the height. And by that height, we mean the perpendicular height, the height of the triangle at right angles from the base. So it means from, for example, this point up to the very tip up here, okay, and the shortest distance between those 2 points. So we need to use Pythagoras' theorem to find the height, because if we were to have a very quick sketch, in fact, let's do that slightly nicer. If we have 1, 2, 3 sides of a right angled triangle, then what we can do, we know that this length is 7.5. This length on the bottom will be half of the original base that we were given, which was 6, so this must be 3, and then we can work out what the height is. So we've got a squared plus b squared equals c squared. Then h squared plus 3 squared will equal 7.5 squared. That's the information we were given. So we can then work out that h squared will be 7.5 squared minus 3 squared, and press equals, and that comes out at 47.25. So we can calculate what the height is. The height will be the square root of that, which is 6.87. Now, I've written 6.87 here, but on my calculator I have the full answer, 6.873863542. The reason being, we're now going to have to use that answer to calculate the area of the triangle. The area is the half the base times the height. So, first of all, let's just get rid of that. So we've got area of the original triangle is a half times the base. Now the original triangle has a base that's 6 centimetres times the height, and the height that we found, which I've written as 6.87, 0.87, but of course actually in reality it's got more decimal places than that. So on my calculator, using that previous answer, I'm going to multiply by 6 and then multiply by 0.5, and I get my answer, which is 20.621 ... centimetres squared, which I'm then going to round and say, well, that's 20.6 centimetres squared to 3 significant figures. And there we have the answer. Okay, so the main point here is, if you have an isosceles triangle, you can still use Pythagoras' theorem by simply splitting the triangle in half. The important thing that you need to remember is to halve the base if it is that you're going to use Pythagoras' theorem, or certainly maybe draw a little sketch like we did and put on the correct values. Any questions, let me know. Again, if there's any questions in the next exercise that are causing lots of issues, I'll do worked solutions for you. But otherwise, good luck, work your way through section D.